Good day, guys. This is your tutor engineer. Today we'll be doing our very first lesson on physics, motion in one dimension, particularly focusing on distances and displacements. So let's start. Okay, the first question is define the distance. So the first thing you must say there is that distance is a scalar quantity, which means it doesn't take into account the direction and the total path length traveled. And then it has its vector counterpart, which is called displacement, which is a vector quantity, which means you need to take a direction into account, and a change in position from initial to final position. So it is measured in meters, also the distance is measured in meters. Now the velocity is also a vector quantity, which is related directly to the displacement. I'll do more examples to explain what does that mean. And the rate in change in displacement. And then the acceleration is also a vector quantity, and a rate in change in velocity. So the acceleration's unit is meter per square second. Then the unit for velocity is meters per second. Now let's go to 1.2. Determine the distance. For number 1, the second part is determine the displacement with reference to the starting point in the following cases. 1.2.1, a man walks 50 meters in a northerly direction. The man walks 50 meters in a northerly direction, turns and walks 150 meters south. Now let's draw the motion. Let's make a picture. So the man walks in the north 50 meters, and then it turns and goes to the south by 150 meters. Now to calculate the distance here, we'll say distance is equal to the total length travel. So it's 50 plus 150, which is 200 meters. Since it doesn't have a direction, so we don't write a direction. So now the displacement however is different, where you need to take the directions into account. Let me choose a different sign to show you that. So you're going to choose north as positive and then south as negative. So here we'll say plus 50 to the north and then minus 150 to the south. That will give us minus 100 meters, which we can say therefore the displacement is 100 meters south. Okay, because you need to take into account the direction since you're dealing with a vector. Okay, that is question 1.2.1. Now let's do question 1.2.2. A lady walks from point A and B and from B to C in 30 seconds. Okay, the path for the lady has been shown in this triangle. So let's choose another like a purple color as well. So Roman figure 1, the distance would be the total length the lady has traveled, which is 50 plus 100, which will give us 150. And then the displacement would be the relative change from the initial position to the final position, which is 110 meters. Since you need to take direction into account, you can say 110 meters east, since it's kind of facing this way, to show that it's a displacement, which is a vector. Okay, now we're done with that question. Now let's do the final question for today. A person runs once around a circular track that has a circumference of 400 meters. He stops when he gets to his original starting position. So you need to take note that his starting position and final position are one and the same. If he starts here, he's going to end up here. So now we need to calculate the distance. The distance is actually the total length the person has run around the track, which is 400 meters. That's it. And then, however, the displacement is the change in position from the initial and the final, which is the displacement will be 0, since the person started where he ended off. Okay, I hope you understand today's lesson. If you liked today's lesson, please subscribe and stay tuned on the next lesson in physics. So we'll meet again next time. Cheers.